So this final type of quadratic here we're going to look at, right? It's often called the difference of two squares, okay? A difference, of course, because there's a minus there, yeah, taken away. And you might notice here that they're both squares, aren't they? 16 is a square number, because it's square of 4, isn't it? And of course, x squared is a square number. It's the square of x, okay? So how do we factorize this, right? You might think, oh, because there's two terms, you might only have a single bracket. But this won't have a single bracket, won't it? Because there's no common factor there, okay? They're completely different, aren't they? It's going to have a pair of brackets. And we can do this really quickly, okay? And in the future questions after this, I will do them quickly, okay? However, for the first one, I'll show you sort of how we can do it quickly and why it sort of works. What I want you to think of this here, okay? It's a two-term sort of quadratic, but I want you to think of it as a three-term quadratic, okay? So we could write it as x squared plus 0x, yeah, minus 16, okay, right, because there's no x's there, isn't there? There's no x term there, so it's 0x, essentially, all right? So when I go about factorizing this then, of course, well, I would normally then put x in both brackets, wouldn't I? Because x then multiplies out to give x squared, okay, with the first step. Now, we need a pair, don't we? We need a pair of numbers then that multiply to give minus 16 at the end, okay? Now, when you think of the pairs for 16, well, we've got 1 and 16, haven't we? And we've got 2 and 8. And then the other pair is 4 and 4, yeah? Okay? 16 is a square number, yeah? And when with a square number, you'll have a pair that's the same, all right? And that's really helpful because if you think about it, with the pair there that's the same, I can get it to add up to give 0, yeah? When you've got a pair the same, all I've got to do is make one of them positive and one of them negative, because then they will cancel each other out effectively. Okay, let's put it in. X plus 4, x minus 4. Okay, so, you know, if you want to, you could expand this to see, look, when you do first, you get x squared. Outers, you get minus 4x. Inners, you get plus 4x. And then last, you get negative 16. And the outers and inners just cancel. So you get x squared minus 16. Okay, so it works. Right? It only works with squares. Okay, because with squares, you get a pair, as I said, that are the same. And you can make one of them positive, one of them negative. Okay, so only you've got to look for squares, essentially. Okay, and what we can do, we can think, okay, well, I square x here and I square 4 here, and I can just put the pair of brackets down straight away. So we'll see that now in the next question. Okay, so here, again, you know, you don't have to go through the long process to put 0x in there. You can just think, okay, two brackets, x and x, okay. I need them to multiply to give 25, okay, and of course then add up to give 0. Well, it's going to be positive 5, yeah, and negative 5, okay. So you can just do it straight away if you think through that process there, okay. Now, with the next one, okay, this one looks a bit more complicated, but actually it's really as straightforward, because if you see here, well, that's a square, as we've seen already, but that's a square as well. The whole thing is the square of 3x, if you think about it. So when you do your difference of two squares here, okay, you just look at what do you square to get this? Well, it's 3x, okay, because when I square 3x, I get that. So write that in both brackets. And what do I square to get 16? Well, that's 4. So I'm going to put positive 4 here, negative 4 here. Check it if you want, multiply it out, and it will give you what we want. Same here. I'm sure you can spot here that these are difference of two squares again. Okay, that's the square of 8, isn't it? And this is the square of 5x. So in both brackets, 5x plus 8, 5x minus 8. Okay. Let's look at the next one. Now, you look at this and you might think, could be a problem now, because this isn't a square, isn't it? 7 isn't a square, 28 isn't a square, okay? So, we've got to do maybe a little bit more work. But when you look at this here, you can see clearly they're not squares, okay? There's a minus here though, okay? But when you look at it, you can see there's actually a common factor here, okay? 7 goes into both. So you could, first of all, do a single bracket, okay, and factorize out the 7, okay? So I'll have a bracket there, and factorize out the 7, because 7 is a common factor. What do I times by 7 to get 7x squared? Well, that'll be x squared. What do I times by 7 to get negative 28? Well, that would be negative 4, yeah? And then when you do that, you'll see then, in that bracket, look, I've got the difference of two squares. That's the square of x, that's the square of 2, of course. So what I can do then is keep that 7 there as a multiple outside, and then two brackets. Well, I square x to get x squared, and I square 2 to get the 4 there. So one of them is plus 2, one of them is minus 2. Finally then, again, similar to this one here, okay? You look at this and think, well, they're not squares. 20 isn't square. 245 isn't square. No, but let's look for common factors. What goes into both? And, that ends in a 0, that ends in a 5. So 5 would be a common factor. So what do I times by 5 to get 20? Well, that would be 4. So it would be 4x squared there. What do I times by 5 to get 245? Okay, well, 5 goes into that. You can divide it and you get 49. Okay, look in here. I've got two square terms here. That's a square term, that's a square term. So two brackets, 2x there to square that. 49, you've got to square 7. So it'll be 2x plus 7, 2x minus 7.